for today, we are talking about glide reflections, and they are a special kind of composition. So it's a combination of two things that have to occur in a certain way. So a glide reflection is a composition of a line reflection and a translation where the translation is parallel to the line of reflection. And you'll see what I mean once we do one of these. So for question number 1, it's telling us we have a triangle ABC. We're supposed to plot those points, and then we are supposed to get a single prime triangle using this and a double prime triangle using this. So first thing we're going to do then is plot the original triangle. So when I plot those points, I have 1, 2, 5, 3, and 3, 4. So here's A, here's B, here's C, and I'm going to connect those. So from A to B, B to C, C to D. So for our A prime, B prime, C prime triangle, I have to move all of the x's 0 units and all of the y's -4. So if I move all of the x's 0 units, that means that they're not changing. And then if I subtract 4 from all of the y's, I get -2, -1, 0. And that becomes my second triangle. So 1, -2, 5, -1, and 3, 0. C prime, B prime, A prime. I'm going to connect those points to make a triangle. There's the first line connected, the second line connected, and the third one connected. So my triangle, the original one, the black one, has translated down 4 units to become the red one. From here, I now have to take that second triangle and turn this into the double prime triangle. So I'm going to have A double prime, B double prime, C double prime. And it's telling me that I'm going to create that new triangle by doing a reflection over the y-axis, which is -xy for the rule. And of course, you can count on your graph paper. So this is -1, -2, -5, -1, -3, 0. And once again, I'm going to connect those points to make that triangle. Here's the first connecting line, and the second, and the third. Now, in this, so far, everything that we've done is exactly what we did yesterday. We haven't done anything different than what we did yesterday. The one thing that has changed, though, is the fact that now they're continuing on and they're asking us this question. Is this a glide reflection? So what I would like you to do is take a look at where your translation occurred. Where was it that you slid the triangle from one to the other? And our slide occurred when we went from the first triangle to the second, because that's where our translation was. So from the first triangle to the second. So our translation went like this. I'm going to draw in those lines of translation movement. So that's the first thing we have to look for. The second thing is we have the line we reflected over. Well, where was our reflection? Our reflection was when we went from the second one to the third one. What line did we reflect over? We reflected over the y-axis. So I'm going to draw in that y-axis. Now, to answer their question, I have to say whether or not I consider this to be a glide reflection. And what you have to do is you have to see if your lines of movement on the translation are parallel to the line you reflected over. So would you say that the y-axis and the A line and C line and B line are parallel to each other? I would. They're all going the same way. So because they are, I say yes. So yes, because the translation is parallel to the line of reflection. Okay, so let's take a look at question number 2. Please plot the points of the original triangle. So in the original triangle, I have 2, 1, 4, 1, and 4, 3. C, D, A. I'm going to connect those points and make a line. So I connect A to B, and B to C, and C to A. There's my original triangle. I'm actually going to put a number 1 on this one, just as a reminder that that was the first one. It says that we're supposed to get a second triangle. And to get our second triangle, we are doing a reflection over the line y equals x. And I know the rule for that is y comma x. So I am taking all of the originals and performing that reflection on them. So I'm going back to A, and I'm performing the reverse 1, 2. B instead of 4, 1 is 1, 4. C instead of 4, 3 is 3, 4. And I'm going to plot those points. So I've got the point 1, 2, 1, 4, and 3, 4. I'm going to go in and connect those points to make a triangle. And again, if we're reflecting over the line y equals x, just as a reminder, it's the line that goes right through the middle of this. So if I was to go back and draw that line, give or take a little bit, it would be the line that goes out there. So that is the line y equals x. If you fold on that line, your two triangles match up to each other. The second thing that I'm supposed to do is a translation. And the translation is -3, -3. So when I go through and do that translation, I'm subtracting 3 from both the x and the y values. So I'm taking these, and I'm basically doing x minus 3, y minus 3. So every coordinate gets 3 taken away from it. So right down the line, -3, -3, -3, -3, -3, -3. So this will give me -2, -1, -2, 1, 0, 1. So -2, -1, -2, 1, and 0, 1. C double prime, B double prime, A double prime. I'm going in and looking for my line, connect those points, A to B, B to C, and then A to C. Whoopsie. And there is my triangle. And again, when you have this done, it almost is like the question we were doing yesterday, but this question does ask us one more thing. It wants to know if this is an example of a glide reflection. You can't answer the question until you find two things. one of the two things you have to find is you have to find what the line of reflection is. And we already talked about how this is the line that we reflected over. Okay, so that's one thing. The other thing you have to find is where the translation is. And the translation occurred between the second and the third. It was what we did right here, between the second and third. So if I draw the lines of translation, I have this one. A goes to A, and C goes to C. Would you say that those lines of translation are parallel to the line we reflected over? I would say yes. So my answer to this question is yes. This is an example of a glide reflection. In question number 3, same idea. We've got an original triangle and two things that we're doing to it. And at the end, they do ask us that question. Is this an example of a glide reflection? So let's go ahead and plot those points of the original triangle. So I have negative 1, 5. I have negative 3, 4. And I have negative 1, 2. So I have A, B, and C. I'm going to connect those points, get a straight line for each of them. I'm going to go A to B, B to C, and then C back to A. In this question, the first thing that they ask us to do is a reflection in the x-axis. So in order to do my reflection in the x-axis, I'm going to need to find a new A value, a new B value, and a new C value. So I'm in charge of finding all of those new values, and it's based on this. So I know that when I reflect over the x-axis, x stays the same and y gets negated, and I am doing that to A, B, and C. So all the x's are the same, negative 1, negative 3, negative 1, and all the y's get negated. In this case, they were all positive, so they all become negative. Plot those points, negative 1, negative 5, negative 3, negative 4, and negative 1, negative 2. So I have A prime, B prime, C prime. I will connect those points. I'm doing A to B, B to C, and C to A. Please note that that was our reflection. So if you want to, when you get to this point, you can certainly say, this is the line I reflected over, because that's what we're going to be looking at eventually. So our reflection was over this line. And then it says that we have to do one more thing, and this is where our translation comes into play. So when we go in now, when we take a look at our translation says that we're doing a translation of 5, 1. So I'm getting a new A, called A double prime, a new B, and a new C. And my rule, if I'm translating 5, 1, is x plus 5, y plus 1. So all the x's get 5's added onto them. All the y's get 1 added onto them. And then I just have to do that math. So this is 4, 2, 4, negative 4, negative 3, negative 1. So it's 4, negative 4. A. B is 2, negative 3. And C is 4, negative 1. Connect those points. A to B, B to C, C to A. When I get to this point, I need to draw the translation lines. I like to draw those in yellow so we can see them. So my translation occurred between the second and the third one. This is what we had, and we turned it into this through a translation. So I'm comparing C to C prime to C double prime, B to B, and then A to A. And the question is this translation line line of reflection parallel to the translation lines? And the answer to this is no, because this is completely horizontal, our line of reflection. These translation lines go over but up a little tiny bit, so they are not parallel. So I'm going to put a note here. It's not a glide reflection. That's the question they were asking, because it's not parallel to the line of reflection. So what we did today with this lesson is the same thing that we had done yesterday, composing more than one thing at a time. This just asks you that one question at the end, wanting to know if this is a glide reflection. Your answer is based on you highlighting the line of reflection and highlighting the movement of the translation. If they're parallel, then the answer is yes. If they're not parallel, then the answer is no.